Hello children, now we are in the last of the chapter current electricity, and in this segment we will discuss potentiometer. Before that we already discussed about Wheatstone bridge and application of balanced Wheatstone bridge, that is a meter bridge. Now potentiometer is a device that doesn't draw current from the source. So it is an ideal voltmeter. The potentiometer has many applications, but we will discuss the two application of potentiometer because these two are in our syllabus. First one is comparison of EMF of primary cell. This circuit diagram is used. And second, determination of internal resistance of a cell. This circuit diagram is used. But first we will discuss its principle. From this part, every year there is a definite question in our CBSE board examination as well as in competitive examination. Numerical, circuit diagram, theoretical, reasoning question. Let us now first principle of potentiometer. First say its circuit diagram. Potentiometer having a long wire. In this diagram here it is of the 400 centimeters, so that is 4 meter wire, even more than that one. This is a battery, a meter, rheostat, it is key. So this one is called primary circuit. First, when switch is on, a current will be in the circuit. Now across the wire, here it is the voltmeter and this one is jockey. The voltmeter, its positive terminal is connected with the positive terminal of the primary cell. Here it is the A. As here its principle is voltage drop is directly proportional to the length of wire. What is from Ohm's law we are knowing V equal to IR and R equal to rho L by A. So V equal to I rho L by A. Now if the constant current flows through the potentiometer wire of uniform cross-sectional area and uniform composition of material, then we can say V is proportional to L or V equal to KL. It is the principle. So in one sentence we can say its principle is voltage drop is directly proportional to the length of a wire. So V equal to KL, where K is proportionality constant called potential gradient. So K equal to V by L, its SI unit is volt per meter. So we here V by L is constant called potential gradient. If we draw the graph between voltage drop and length, it will be a straight line passing through RSN. After the principle, we will discuss its application, comparison of EMF of primary cell. What is EMF? Electromotive force. See its circuit diagram. When switch is on, current will flow in the circuit. Here it is shown by the arrow from the positive to here. It is a cell connected with a resistance box, which is switch on. First, how we can check the connection? Close the switch S1 and press the jockey at point A and see the direction of current in the galvanometer. Now bring the jockey at B and check the direction of current. If in both cases the direction of current is opposite, then our circuit is correct. If not, then we have to check the circuit. What we can check? The positive terminal of cell must be connected with the positive terminal of source battery, and the EMF of cell must be less than the EMF of source battery. If switch S1 is here, S1 is closed, now bring the cell of EMF E1 in the circuit. Let at point J1 galvanometer show no deflection. It means potential difference between A and J1 is equal to EMF of E1 of the cell. So what will be? E1 equal to VAJ1. Now V equal to IR, we have to use the formula. So I rho L1 by A. Similarly, for the cell E2, we will get E2 equal to I rho L2 by A. So E1 by E2 equal to L1 by L2. The balance point will not be obtained on the potentiometer wire if fall of potential along potentiometer wire is less than that of EMF of the cell to be measured. Means the EMF of the cell must be here equal to the potential drop. Means potential difference between AJ1. In that case only there is no current through the galvanometer. Our next application is determination of internal resistance of a cell. First here, see, in place of a cell, a resistance box is added. It is the circuit diagram. Now, when the switch K1 is closed and K2 here open, current now starts. Let at point J1 there is no deflection in the galvanometer. So what we can say, the potential difference across AJ1, means this part of the wire, is equal to EMF of the cell. So as earlier, E is proportional to this length L1. So E equal to KL1, where K is potential gradient. Now if this switch K2 is closed, so that a resistance R from this resistance box is connected across the cell. Now let the galvanometer at point J1 gives no deflection. Means now the potential difference between AJ2 is equal to the terminal potential difference. So if we let AJ2 is equal to L2, then V equal to KL2. Remember earlier we have discussed the terminal potential difference. When a resistance is in the circuit, then that is known as terminal potential difference. Now E by V equal to L1 by L2. Now E equal to, remember the circuit equation, I R plus R. R plus R will be where this R is the internal resistance of the cell and R is the resistance here. So it is the total resistance of the circuit by terminal potential difference is IR. So IR plus R by IR equal to L1 by L2. So from here R by R plus 1 equal to L1 by L2. Thus we can say R equal to L1 by L2 minus 1 into R. So if we see the comparison of EMF and internal resistance, only difference in the circuit diagram in comparison to compare the EMF of the cell. Here a cell is induced, that is also connected with here the A, but in internal resistance application, our resistance is connected across the back here the cell. Next, mind map. Now we are in the completion of the chapter. So in short, how we can summarize the chapter from Ohm's law to potentiometer. See, this is one of the important relation, I equal to NEAVD, or from earlier we can say it is rate of flow of charge, that is Q by T, or it is J into A. What is J? It is I by A. Now here the drift velocity, or before that we can say the Ohm's law. What is Ohm's law? V equal to IR. Its microscopic form is E equal to J into rho, where J is the current density and rho is resistivity, and reciprocal of resistivity is conductivity. Next is drift velocity. Vd equal to minus E tau by m, where tau is the relaxation time. Relaxation time is the time between the two successive collision, equal to this one equal to mu into E, where mu is the mobility of the electron, or this is I by NEA or J by NE. These are the different relation related to the drift velocity. Next is resistance. First, from the Ohm's law, R equal to V by I, or R equal to rho L by A, where rho equal to M by NE square tau. So R equal to M by NE square tau into L by A. Resistance at any temperature T is R naught into 1 plus alpha T minus T naught, where alpha is the temperature coefficient of resistance. Then we studied series combination and parallel combination. Next we studied electric power, that is P equal to VI or equal to I square R, and this is equal to V square by R. After that we studied EMF, internal resistance, and combination of cells. EMF of a cell is V plus IR, where V is the terminal potential difference. What is it? That is the potential difference between the plate of a cell in open circuit, and potential difference between the plate of a cell, terminal of a cell in closed circuit, that is terminal potential difference. So E equal to V plus IR, and now we know from Ohm's law I equal to V by R. So here V plus V by R into R. From here we can find the internal resistance also. Also we studied equivalent EMF in series combination, that is sum of individuals, and in parallel we obtained this relation. After that, Kirchhoff's law of electricity, two laws. Algebraic sum of electric current at any junction is zero, and potential drop and EMF in a closed loop, summation of these two is zero. After Kirchhoff's law, we studied Wheatstone bridge. Condition of balanced Wheatstone bridge is P by Q equal to R by S. An application of Wheatstone bridge is meter bridge, and its application to find the unknown resistance S. And at last, we studied about potentiometer, that is principle and application. You may draw a mind map according to you for each chapter, and that will be very much helpful to revise the chapters in a very short time. Here, few questions given for practice, and remember these questions are the board questions, so important one. This is for the potentiometer. Hope you got it. Next, before starting the next chapter, we will have a test. You will get the question in the next class. Thank you. Have a good day.